Okay, here is 12.7 exploring similar solids, 88 through 90. This is our last notes for the rest of the year, and it's the end, so it's yay. Yay, this is it. Okay, so here we go. The first page says we have theorem 1213. Two similar solids have a scale factor of AB. Corresponding areas is going to be squared. A squared and B squared. And if it deals with volume, then it'll be cubed. A cubed and B cubed. And this is so you don't have to do all those formulas I've taught you. So it's like on the first one, it says tell whether the given right triangle is similar to the right triangle to this. So what I'm looking at is I'm going to first for A, I'm going to take the 10 and relate it to the 5 by checking the ratio of the sides. So I'm going to do 5 over 10, which reduces to 1/2. Then I'm going to do another side, take the 6 with its corresponding side of 3, and I'm going to do 3 over 6, which also reduces to 1/2. And then I need to check the last side, which will be the 14 and the 7. So I do 7 over 14, and this reduces to 1/2. So I have 1/2 on all 3 of the side ratios. That means that these two shapes are actually similar. And the reason is they have a scale factor that is 1/2. If I look at B, I'm going to do the same pattern. The front edge is a 5 to 15 ratio, which reduces to 1/3. If I do the side edge of this, it's a 3 to 9 ratio, which is also 1/3. And then I do the 14 and the 7. 14/7 is 1/2. So these two are good, but that third one is a no. So these two shapes are not similar. And that's because the scale factors do not all match. Okay, on example 2, we're going to be using this concept of scale factors to find the surface area and volume of cylinders. So cylinder A and B are similar with a scale factor of this 2/5. It wants us to find the surface area and volume of cylinder B, given that A's surface area is 96 feet and its volume is 128 pies. So we're looking for the surface area and volume of the cylinder B just using the ratio. I'm going to start out with my 2 over 5, and this is my side ratio, so I'm going to change it to my surface area ratio, which means I'm going to square top and bottom, which means I'm going to use 4 over 25. And this is going to be for my surface area. So I'm going to use the 4 over 25 is equal to, and realize the 4 must go with the smaller shape because it was a 2 to 5. That means the area one would be the 4 to 25 ratio. Since my 4 is in the numerator, the 96 must also be in the numerator, and I'm going to put an X on bottom. Now your goal is to cross multiply and do 4x equals, if I multiply 96 times 25, end up with 2400. I'll divide by 4, and X is 600 feet squared. That'll be your surface area. If I go to the volume, I go back to my original ratio, and now this time to get to volume, I'm going to cube the side ratios to come out with 8 over 125. So I'm going to use this as my proportion, and I'm going to use the volume with the pi symbol for the other side of my proportion and an X on bottom. Once again, I want to cross multiply. And I'm not going to use the pi just yet. I'm going to leave it as 1600 pi. I'm going to divide by 8. And that gives me that the new cylinder is 2000 pi feet cubed for its volume. Okay, if I go to the next page, example 3, I'm now dealing with cones. And it says we want to find the scale factor. The two cones are similar if this find the scale factor. We want to use this theorem that we're given. So I'm going to take my two cones. I'm going to say this one's my A and my B cone. So I'm going to take 108 pi over 256 pi. And my first job here is to try to reduce this to find nicer numbers. Now obviously I can see that the pi's will cancel out. So I actually just have, and let me get out of that. Actually just have 108 over 256, and I wrote this in fraction form in my calculator. It gives me 27 over 64. Now I also notice this is in cubic units, so that means I'm dealing with the volume. Also it has a V in the front. And the ratio that I had here said that my A and the B were just cubed. So if I'm trying to go backwards, I do the opposite of cubing things, which means I have to take the cube root. Okay? The cube root is, once again, math, and the number 4 gives you the cube root. Type in 27. And I do math 4 again and type in 64. And when I type in the cube root of 64, it gives me 4 as my answer. And 3/4 is my scale factor. Alright, example number 4 says a store sells balls of string in 2 different sizes. The diameter of the larger ball is 1.5 times the diameter of the smaller ball. If the ball of strings cost $4.99 and $1.49 respectively, which ball of string is the better buy? So we've got this 1.5 times the diameter, and we're looking for which one's the better buy. Well, if I take this setup here and I say, okay, I have 1.5 to 1 will be the diameters of my spheres that I have actually taking place here. And a ball of string is being wrapped around each other, making it a sphere. So that means this is dealing with volume. So that means I'm dealing with the actual volume of those values. Cubic, actually, if I can get my words out. That means this is 3.375 volume wise, and the other one is just 1 for my ratio. So if I take my values and say, okay, so I have the $4.99, in the 149, I'm going to set it equal. Okay, $4.99 divided by $1.49 is 3.35 of 1. This represents the ratio of price. And this one, that would actually be an 8. So if I wipe that out, that'll actually be an 8 because we're dealing with money. So this is the ratio of the diameter. So if I compare my numbers, the price ratio is 3.35 for $1 is changing that amount, whereas if this is changing Here, it's a less, this is a more change because 3.38, and this one's a 5. So that means your price is increasing less than the actual diameter. So the larger this gets, the cheaper it actually is. So the better buy, it will actually be the bigger ball because the diameter is changing faster than the price. Not by much, but it is changing faster than the price is changing. So that makes the bigger ball of string the better buy. Okay, here's your independent practice 1 and 2. I'll give you 5 minutes to work those, and then I'll start working all of the problems. On number 1, I did the radius ratio was 3/5. The height ratio was 410 reduced to 2/5. Since 3/5 and 2/5 do not equal, means it is not similar. For that problem, they're not similar because the ratios are not the same. If I look at the other one, okay, so I do the radius ratio again. This, I have to cut this in half because it's a diameter, so that would be 2.5 over 5. And then I'd have the height ratio is 7.5 over 15. Since there's decimals there, I'm going to use my calculator. Okay, that reduces to just 0.5. And then if I do the same thing, 7.5 divided by 15. Oh, shoot. I get 0.5. So these both equal each other, therefore these guys are similar because their ratios are the same. Okay, if you got these two correct, give yourself a check mark. And then we'll go on to the next page. Hopefully you've already worked them. It says cone A and B are similar with a scale factor of 5 to 2. The surface area and volume of cone B are given. Find the surface area and volume of cone B given that surface area cone A is that number, 2356.2. And then the volume is 7450.9. So I'm going to start out with 5 over 2. And I'm going to the surface area first. So that means I got a square top and bottom. That makes this 25 over 4. So I'm going to use 25 over 4 equals, and since I'm done with surface area, this says A to B, so that means the 5 is my A and the B is the 2. Cone A has 2356.2 over X. I'm going to cross multiply. Okay, that gives me 9424.8 is equal to 25x, and then I want to divide that by 25. Gives me 376.99, and that would be centimeters squared, would be your surface area. If I go into the volume ratio, that means I'm going to take the 5 and the 2 and now cube them. That means this will be 125 over 8. So if I use this ratio, plug in your 7,450.9 over X, cross multiply. Gives me 59,607.2 is equal to 125x, so now divide by 125. Gives me 476.86 centimeters cubed will be the volume. Okay, if you got both of those correct, give yourself another check mark. So once you got those correct, then number 4, it wants us to find the scale factor between cylinder 1 and 2. If I look at the ratios, I notice they're dealing with surface area, so that means these are all squared. So to go backwards, I do the opposite of squaring it, which means I'm going to take the square root. So I want to take the 288, because this is cylinder 1 to cylinder 2, over 128, and I want to first reduce. See if I can reduce this. So I'm going to do alpha y equals in 1, 288 over 128, and that reduces to 9/4. And now to get to my scale factor, I'm going to now take the square root of 9 and the square root of 4 to come out with 3 over 2. And that represents your scale factor. Okay, on number 5, the last one, they're dealing with a store sells bird seeds for 2 sizes of cube-shaped blocks. The smaller block measures 3 inches on an edge and sells for $1.99. The larger block measures 5 inches on an edge and sells for $5.99. Which block is the better buy? So if I'm looking at my 2 ratios, I have a 3 to 5. I'm going to be dealing with volume of how much bird seed they actually can contain, so that means this is going to 27 over 125. If I look at my 2 prices that I'm dealing with, the price of the 3-inch is $1.99, and the price of the 5-inch is $5.99 that we're comparing. And another way to compare things is actually to go ahead and divide them and find out how much it is for just 1 cubic. So just to show you a different twist on how to compare prices, I'm going to take the $1.99 and divide it by its 27, which gives me approximately 0.03. I'm sorry, 0.07. for the smaller cube, and then $5.99 divided by its volume, which would be 125, is approximately 5 cents per cubic foot or cubic inch. So if I'm looking at the 2 prices, the one that's basically 5 cents per cubic inch versus 7 cents per cubic inch. So if I'm looking at the 2, the 5 cents gives me more because it is the bigger size. So we're going to say that the bigger block of birdseed or cubes is the better buy, because you're getting more for a lesser price. Okay, if you got that one correct, give yourself your last smiley face from me for the year, because this is the last one.